This conference will now be recorded.
Okay, so what is Terraform? All right, so really, I think your question should be centered around it. And I get this a lot because people are trying to figure out, if I learn Linux, what do I do next? And why should I do these things next? Well, when we're talking about looking over the landscape, and this is a long way around the answer to your question there, Russ, but just bear with me. When we're talking about what I see and what's going on across the industry, and if you can, there's DevOps reports, right? So there's several, as you can see here, like the state of DevOps report, DevOps trends to get the report, state of DevOps from Google, and so forth. And so they all, and I pulled this up last year, the Dora report, right? Um, so let me go here, use Dora report. I forget the lady name off the top of my head who actually created this. But basically, in the Dora report, what you'll find is a comparison of high functioning teams to slow functioning teams. And really, what we want to be is a high functioning team, right? And then we also want to be also very agile, right? We don't want to be waterfall. We want to be very agile. So how do we get there? What what does all this stuff mean? You're saying you want to be agile, you want to be a high functioning team, you want to do all these things, but how do we get there, right? So when we start looking at, say, I am a company and I'm looking to move to the cloud, maybe my strategy is I'm going to be maybe what we call on-prem. Some people call hybrid, some people don't. Maybe I want to be on-prem and maybe I want to be in the cloud, right? So if I'm on-prem and I'm using something like on-prem tools, and let me go over these real quick. VMware is one tool. Tanzu is another tool. OpenShift is another one. OpenStack is another one. Azure Stack is another one, and I'll explain these in a minute. AWS Outpost is another one. But let's go backwards. So AWS Outpost came out probably like maybe about 3-4 years ago, and it was in to compete with Azure Stack. So if I'm a company and I want to move to the cloud, it takes a lot for me to um, build a cloud and have it on prem. So companies such as AWS and Azure came out with products that could enable them to have an actual physical box like it was deployed in a data center somewhere that has all their software on it. So if you look at Azure, I mean not Azure, if you look at AWS Outpost, and I actually want to do images. If you look at AWS Outpost, here's an example of it here. Um, you have this rack that gets deployed onto your site on-prem site, and depending on what you want to order, because there's so many different things that you can order with it, right? Let me see. Here's the pricing. So just to give you an idea here, what we're talking about, right? You're talking about $5,000 a month for 4 M5, 12 extra large instances and so forth. So all upfront cost is 169,000. People were not when this came out, there was nobody getting certified on it because the information wasn't out there. So people were writing white papers, they were going around and looking up what it could be and guessing and so forth. So now you can get a certification, and this may be your realm, right? But you stick with AWS Outpost. So AWS Outpost that allows you to have like your AWS instances that you have in the cloud, like you have your services in the cloud. I can have this on-prem. Same thing with the situation with Azure Stack. The same thing when we start getting into, I'm gonna build out OpenStack, right? So OpenStack as a product itself, as an open source product, just gonna type OpenStack, comes with many different services. So let's go and look at OpenStack components. So Red Hat is one of the biggest contributors to OpenStack. But what you'll find is I can mix and match several services, right? I'm just on one page right here when it comes to this. But now, to answer your question, Russ, is okay, I got all these different bare metal hardware machines. I have stuff in the cloud, and I want to be a high functioning team. How do I get my application deployed to something that's on-prem and in the cloud? And when I say that, I'm saying it from this perspective. Say I have on-prem AWS Outpost, but I also have stuff in Azure, and I may have stuff in Google Cloud. Now, each one of these particular clouds, in particular, AWS has their own what we call infrastructure as code. And that's what Terraform is. It allows me to create my infrastructure as code. And when I say that, I want to go back over here to my GitLab project, and let's look at this one here. And let's look at a Kubernetes deployment, and let's look in infrastructure, and let's look at our main.tf. So here, I'm just declaring what I want to deploy to my cloud. Now check it. I could write my code far as Terraform goes, and I can write it for AWS using Terraform. I can write it for AWS Outpost. I can write it for OpenStack, and it's all dependent on the providers, right? So what Terraform has is a set of providers that I can come in here and grab. So one of the ones is, I just showed you AWS, and another one is Google Cloud, right? Here, they're providers, right? So I can come in, and if I want to deploy, and we can go to, let's go here, cloud.google.com. And I want to, I'm getting on the console. Now, if I want to come here, and I'm going to view all products, and say I want to do something with compute instances, I want to do something with storage, I want to do something with networking, analytics, databases, and so forth. Depending on what's in the provider for GCP, I can go and create what we call infrastructure as code. Why does that make a difference? It makes a difference if I am going to understand what's deployed in my cloud, right? So say I got AWS, I have AWS Outpost, I have GCP, I have VMware, I also have Oracle Cloud. I don't want to go into every single console in every single region in every single project to find out what in the world is deployed into every last one of these, right? I don't want to do that. I want to be able to, one, be able to look at the state of what's deployed. So in Terraform Cloud and in Terraform Enterprise, Terraform Cloud is Terraform Enterprise. It is their way of saying, hey, we're not going to have you go through everything Tamika went through. That's kind of how this project got started. And have to worry with standing up Terraform because it was so complicated, and you're in a restricted environment, say GovCloud, and you have to have certain STIGs and all that, this, that, and other, and certain compliance rules and stuff like that. We're gonna take care of that for you so you can do the real work, right? So inside of here, you end up connecting GitLab to Terraform Enterprise, and I'll go on the back end here. Organizations. I got different organizations set up, got different tokens, but here I can go and look at this organization, right, and have my settings. Right here, I have my different teams. I got my API tokens set up and so forth. I can write I can actually write my own providers and so forth and whatnot, but I can interact with this particular Terraform Enterprise as if Terraform Enterprise in the cloud as if it's regular Terraform. But what ends up happening is the way Terraform works is Terraform saves the state of your actual infrastructure. So instead of me going out to all these different locations to try to figure out where the hell everything is at, I can just do a query on my state of my infrastructure, and it give me, depending on what outputs you have. And when I say that, I'm talking about outputs here. Right here, I'm just spitting out the public IPs of my master node, and then of my workers, and then what region are they in. And so I can print that stuff out. And so your state helps you to figure out what's out there, right? Terraform, unlike Ansible doesn't hold the state. And if I want to update something like in here, if I want to come in and I want to change a tag, well, instead of me redeploying the actual infrastructure, it'll just go in and change the tag for me. But if I want to rename or change the size of the instance, it's going to go out, grab the state of that infrastructure, and then it'll tell you what is going to change and what if it's going to create and destroy. This was tied up to this right here is tied up to Terraform Enterprise, but I can come down here and kind of show you what I'm talking about. So here, this is where Terraform really performs, right? So you have what we call a Terraform plan or initialize, and then, well, you should validate first because you need to validate your code and format it. But those are what we call pre-commit scripts. We'll do Terraform, right? So in our pre-commit hooks, right? Will come in, and this is what they have for their pre-commit hooks, but they have hooks for Terraform docs, formatting, Terraform Flint, Terraform Lit, I should say, Terraform security, and Terraform validate and Terrascan. All these are what we call, and this is what I get into, this is why I want us to finish up with Linux so we can start getting to Git flow and understanding, like when we check in our code, we have our pre-commit hooks. And our code is in our pre-commit hooks, we're going to go through and, make sure that our formatting is correctly, make sure our linting is done, make sure we're not pushing any PIM keys up to the cloud. We're going to validate that everything is done correctly. You're not leaving out any variables that are just not being called. We want to be efficient with our code. All right. So we start getting into from that perspective. Once we got our pre-commit hooks going, we commit our code to GitLab, and then here we're doing a Terraform initialize. And so that just goes out and grabs, looks at where's the back end. Is it local or is it out in some cloud? You want to keep the back end, and I don't want to get into Terraform workspaces. That's just another talk. But in order to find out what's going on with everything, you can create a backend inside an object store. And when I say object store, the object store can be in Google Cloud. You can also create an object store inside of Linux as well too. So you can turn a bare metal machine into an object store inside of Linux. It's called Minio object store right here, right here. Minio is built on cloud native technologies, and you can just turn a bare metal machine or even a VM into an object store where you're storing the state of your infrastructure. But another time, another place, another fun time. But basically, that's what Terraform allows you to do. But all the things that I mentioned are things that you're going to need to know, whether you're looking at it from a DevSecOps perspective or you're looking at it. A lot of jobs now are saying Linux system engineers or Linux system administrator, and all these things fall under that as well too. So it's that's what Terraform does. Cloud formation is strictly just for AWS, but Terraform allows you to go to any cloud. I hope that answered your question. Try to answer it so you know how to apply it and know what's going on. No? Anybody got questions? Everybody
No,
understood it?
that's it.
Okay. All right. So what I did in here, here's a Terraform initialize. It is a Terraform plan, and you can see here, everything that's a plus, it's going to get created, right? And everything that you see here are things that I can define. And I shouldn't say things. They are variables within the resource that I can find that, and I know that even before this gets created, planned from the actual provider itself. And then if we go back on that to see, that's a Terraform apply. And so now in my Terraform apply, I don't do it like that. In my Terraform apply, you can see that it was going through and creating stuff. Like here's the update that I had, and then local exec. I can write scripts and stuff like that. And then here's my outputs, right? Here's the outputs that I have. Here's my Terraform show, because at this point, I didn't give a back end definition. The back end is actually being held on the Docker container that gets pulled down for this GitLab runner, right? And that's a bad place to put it, because now I can't share this with the team, because the team then wouldn't know what's actually deployed, right? If they just did a query for the state. So this is, and I'll get off my soapbox here. This is where Terraform workspaces comes into play. So with Terraform workspaces, I can then set up my back end, and I can set up my back end, and I could also set up where I have multiple projects to talk to multiple clouds. So say I could do Terraform workspace new, AWS East, US East, or US East 1, US East 2, or whatnot. I can set that up for whatever projects and stuff. And so I can go in and out of those projects in order to utilize, Terraform. So I think everybody should be, once we get done with Ansible and once we get done with Linux, everybody should be going for the Terraform certification. I think it's just one of those certifications that you just have, and people just, with cloud Terraform, you don't even have to get Ansible certified, but that's the RHCHE. And you don't have to get certifications in any of these things, but they all help when you're going for your job, if you know about them and know about them in depth enough to get hired, because you're going to find that every company uses Terraform in their own way, or how they do commits, how they use Ansible and so forth, you're gonna find that people do it their own way. Does that make sense? And this is
Yes.
all right, cool.
Absolutely.
All right, so that's what that is. The OpenStack stuff, where that comes into play, that's on-prem. And there are different, what's the word I'm looking for? Certifications that you can get with OpenStack, right? So you can go and do the D0180 from Red Hat, right? And it's just basically what is, OpenShift and containers and so forth, right? So I'm going to try to pull up a job listing from Red Hat that was sent to me. Let me see, it's called containers. Red Hat, let me see if I can find it. So that you can take a look at the job description. Let me see. Was it on this one? It might have been somewhere else. All right, here is one. This is from 7/29. All right, so let me blow this up some. All right, so OpenShift remote to start and transition to New Jersey. This was months ago. As you can see here, Red Hat OpenShift engineer, Newark, a Linux support engineer, senior Linux engineer with OpenShift out of Oshkosh, Wisconsin. What I want to show here is what they're looking for, right? Linux engineer, understand Red Hat OpenShift, OCP, experience with Linux automatically. And then you see right here, container-based implementation, AWS, ECS, EKS, EMR, and Kubernetes. So OpenShift, Kubernetes, Linux, Terraform, application deployment, they all go hand in hand. Nice if you understand IBM Cloud Pak, right? And then if we hop down here to this one here, and this one is in Wisconsin, and you can see the environment contains 350 Linux servers ranging from RHEL 5 to RHEL 8. RHEL 5 is out of support, but they probably got applications that they can't migrate, no one has figured out how to migrate them to microservices or whatnot, and nobody probably knows how it works. So they stay on RHEL 5, they stay on RHEL 6, and those are they're out of support. And then here they're talking about the satellite server. Here we go with Ansible, then understanding STIGs and OpenShift, and here on-prem, right? OpenShift container on-prem and Azure. And so that's why I say something like a Terraform helps you out with maintaining the infrastructure down to how to secure or how to do a deployment of your network and so forth. And I'll show you some stuff with that as well too. So when we're talking about Terraform registry. So here we browse providers. Here's a list of their providers. Bring it down some. So you can see these are the big main ones, but they have stuff for Nomad, verified providers. They got stuff for, I can't view all, but here we can go over here and look on the side. You have logging and monitoring. You have networking, security and authentication, web services, CI/CD. So if we click on CI/CD, you'll see Artifactory, you see GitLab, you'll see X-Ray, which is under Artifactory to do an inspection on containers in a live environment. When I say in a live environment, in real time, like basically your containers are being scanned constantly. And then if you click over here and do logging and monitoring, you'll probably see stuff with Splunk and so forth. Speaking of, did y'all see about Splunk being bought? Splunk purchase. Yep. Splunk acquisition, $20 billion acquisition from Cisco. Right. That's what they're offering. Right. So when we look at Terraform, that's what you're looking at with Terraform. And CloudFormation doesn't give you this. It only works in AWS. And then Azure has what they call Azure DevOps, which is like they're all in one thing. But you can take GitLab and GitHub and roll them as your platform and integrate with any of those things. And I don't have my chat up, so I don't know if anybody's asking questions. Let me pull it back up. No questions. All right, cool. All right, so let me see who all is here. View everyone. All right, let me see who's all here. Mac, what's going on? Tamika Johnson, this is not your first one, right? It's not your first time, right, Tamika? Tamika, yeah. No, yeah, could be. All right, maybe you're not there. All right, so let's get busy. We're gonna close all these out. We are going into chapter 5. Hopefully we can do chapter 6. I should have went on high performance teams, but I can say that for 1 hour meetings. So in chapter 5, we're going to okay, yeah, cool. Oh, we're gonna discuss files. And you've seen me do this 1,000,001 times with files. So let's go in. The lab environment is up. Let's hop on the classroom. Let's turn on cut and paste. Let's get logged in. Is this screen big? Looks big. Let's see. Activities. Zoom in. All right. That looks extra big to me. All right. So now let's go to course. And we're in chapter 5. All right. So they give you your objectives. They're talking about redirecting output from a file or a program, editing text files, and you have your options here on that. Then they give you a guided exercise. I'm not going to go through that. We'll do changing the shell environment. I won't go through the guided exercise. I may like do a summary on the guided exercise and lab review on these, right? So let's get busy on redirecting. I mean, I haven't really fully looked at this in some time, but that's okay. All right, let's get that going right there. I won't explain that until I do this. All right, so there's a couple of things. We have different editors when it comes to Linux. All right, so you have Pico, Nano, Vim, Emacs, that most people like to use. Those are generally the ones that most people like to use. So let's go. I'm a Vim person. So Vim is guaranteed to be on all your boxes. So Vim cheat sheet is your friend. And so also the Vim tutor is your friend. All right. So here's the cheat sheet. There's also Pico. So let's go over here. So who am I? It's gonna tell me who I am at this point in time. I'm a student. I logged in with the password student. I'm student, right? If I type VI and I hit double tab, it's gonna show me everything that started with VI that's in my path. When I say in my path, I mean in my path of what I have defined as my path for my environment. When I'm saying that, I'm talking about if I do an echo on $path. These are the paths that possibly have binaries in them for me to run. And 9 times out of 10, what you see here with VI double tab probably came from user bin or user S bin, more than likely user bin, right? But it's just giving me what my options are when I type VI. I'm reiterating things such as double tap with tab so that you can understand that you can double tap with tab. I'm also going to be reiterating commands just to spark, drill things into your head. So if it seems redundant, good, right? Who am I? I am student. That's how I find out who I am. How do I know what who am I tells me? I just do a man on who am I, right? Print the effective user ID. That's really what that is, right? So now I'm gonna type clear. And the other thing I wanna do is say, well, where am I at on the system? PWD, right? So I'm gonna be doing this throughout the night, just so you can start saying things in your head, like, right? And then remembering what those is. You have to practice repetition, okay? All right, so now I wanna look at the commands that I just typed. How can I do that? I can do a couple of ways. I can do a history to show me the history of the commands that I've typed. I can also do a reverse search, and then I can type in W or whatever, and it's gonna find things that commands that contain the letter W, right? So see that. Control C meaning cancel what I'm doing. If I did a Control Z, it would have threw it into the background. It would have still been sitting there, and I would have to bring it back to my foreground in order to get it to work. You're gonna find out about jobs later, right? Everybody with me so far on what I'm saying and what I'm doing and the commands and how they flow and what we can do and how we can find things out? You can just type a 1 in the chat if you don't want to talk. So I'm a CD over the temp, and then I'm a CD dash, and that's gonna take me back to where I was. I'm gonna CD over back to temp, and then I'm a CD to home by using CD tilde, right? I could have just CD to temp and then CD dash, and then it would take me back, right, to my previous destination. So reiteration here. So let's go over to temp. Let me see. So they got some files in here. How do I know they're files? ls-l gives me a long listing. If I'm not sure about ls-l, do a man on ls, and then you can search in here for the -l. I won't bore you with that, but you have your options. Remember, you have a command, then you have options, and then you have arguments, right? So in this case, ls is the command, -l is the option. And let's say I want to do that on Nick 1, right? So I gave the command as ls, the option is, ls is the command, the -l is the option, and then the Nick 1 is the argument. But what I do know, if by looking in the front here, that Nick 1 and Nick 1 old and Nick 2 old are all files. And I know that just by looking at one, you can play the color game, but I advise you not to. But you can. I can look at it and tell like it's in white. That's a actual file, and if it's in blue, that's actual a directory. But that may not be the case. Somebody can switch that up on you and not give you any color. So you have to come up other ways to figure this out. So I'm going to clear. Then I'm going to do ls. So then if I do a file on nic1, this tells me it's an ASCII text file. So using my editor, which is Vim that I'm using, and there is an editor called VI, but Vim is the enhanced editor that gives you colors. If I do and Vim on nic1, it just has ETH0 in there. And you can see down here at the bottom is read only, right? But again, this is just me using an editor. So let's see if Pico is installed. I can do which Pico. No Pico is installed. I can do which Nano. But Nano is installed. So let me clear and let me do Nano nic1. All right, so now you see the difference between Vim and Vim and Nano. So you see, when I open up in Vim, I had to you should come over here, use your cheat sheet, but if I wanted to manipulate the file, I have to hit I for insert, and I'll go back and do that. But I just want you to show you that you don't have to rely on Vim, even though I think you're a genius if you do. And you'll get into a war and people tell you, don't stop shaming people for not using Vim, blah, 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 blah. I'm going to shame you. I'm just playing. But look, if you want to use Nano, and then you wanted to edit this, you have what we call at the bottom a menu to help you out, right? You want to read the file, you want to spell, you want to do this, that, and the other. I'm not a fan. I think it just takes too much work. All right. So I'm going to do what they do at the bottom, as I'm going to control X, and that is going to get me up out of there. Woohoo. My life is now saved. All right. So
I think one
now,
of the reasons a lot of people prefer Vim is for its
what'd you say?
global search. I was saying, I think one of the reasons most people prefer Vim is because of its global search and replace and other things like that. When you're editing like configuration file, where you have one string and multiple instances of that string in that file, it makes it easier to find as opposed to Nano. So yeah, I support you on that. Vim is the way to go.
Yeah, but here's the other thing. If I want to search this file, I don't need Pico or Nano to search that file, right? I could simply let's just do a cat on let's just do a cat on nic1, right? Just for because I think that's what I have access to, right? But if I wanted to search a file, I could easily just use grep or awk or set or cut or whatever. But those are regular expressions. I don't necessarily have to use Vim in order to do that. But most people use Vim because when you get started, most people probably start out in Vim, and most people probably teach in Vim, and then some people get discovery and they're like, oh, I can use Visual Studio Code and just double click on this and it'll open it up, and then I can just edit it, and then I hit file save. But here's the thing, if I'm sitting down and I don't have if I don't have a GUI or whatnot, then what can I use? So this is where, the war starts with Vim or Nano, Pico, whatever. I like Vim. I've been using it. It just makes sense to me. But there are others that you can play with. With that being said, when we are looking at, let me show this. Nick. Hold on, Nick one. All right, that didn't show the colors. Let me sudo to root real quick. So I'm sudo -I. Oh yeah, let me get my password in there. I'm a CDO to etc. All right, this is what I think Vim kind of helps you with the enhancement. So if I VIG shadow, right? I don't get any colors. Let's see if we get colors with Vim.
Vim gives you colors.
Yeah, I know, I'm just showing that it does. So when I do my up arrow and then I do a control A, make sure I'm in here to get back to the beginning of the line, and then I do Vim, you see I have the different colors that come into place. So some people like to use old school VI, some people like to use old school Vim, some people like to use Nano, and some people like to use Pico and Emacs. I find people who are doing AI, machine learning, um, natural language processing. They use Emacs. This I don't want to tell you the standard is Vim, but I am going to tell you the standard is Vim. But I'm also going to tell you to explore editors so you can find out what you're most comfortable with. Vim may not be comfortable for you, so that's what I'm gonna say to that question, right?
I think I'm the only person at my job that uses Vim. They all use, what is it? VS Code or whatever that is.
Yep. Like I said, some people use VS Code and they check their code in, they're cool with that, they get file saved, they get plugins, they get this, they get all these other things. And so, I'm old school. I don't really need all that stuff. I just need to get on there and figure out what the problem is and keep it pushing. I just don't need all that stuff. But for some people they do. And I get it. So this first picture here is they're talking standard in. So they're saying, hey, on the keyboard, you got standard in. And then they're showing you standard out is a 1 and standard 2 is an error. And then they got other files. But let's talk about this because we're going to get into redirects. So let's do an example of some stuff. So let's clear. Let's cd over to temp, and let's make a file. So there's several ways to make a file. I can use touch and then append something to the file. I can use Vim, I can use Nano, I can use Pico to create this file. We're gonna use Vim to create this file. Now, we're just gonna echo some stuff into a file. So let me show you something. So if I do echo hello class, and then redirect that to a file called class.txt, it's just gonna create this file and put what I have in double quotes inside of class.txt. So what is in class.txt right now? Well, how can I find that out? Well, first off, I know it's a file. How can I verify that? I can do file on class.txt. It's an ASCII text file. All right, cool. We know that I can use my Vim or Pico or Nano. So, but I don't want to open the file. I just want to read it. So let's do a cat on class.txt, right? So now I see that the information is there. But I can go one step further and say, let's do Vim on on class.txt. So now on the first line, when I open it up, I want you to notice some stuff here. At the bottom, you can see I have in the H, you see I'm in column 1, row 1. I think it's column and then rows. Let's find out. Okay, so it's rows and then columns. So the first one is the row and the second one is the column. So the H is in the first one and I'm going right here, right? The H is in the first, it's in the first row, first column. The E is in the first row, second column. This comes into play when you want to get fancy with offset and grep, where you want to go through and I want to replace everything rows 5 through 10 or column 12 or row 1, column 12, right? You get really fancy at that point when you want to do a offset grep or what have you, right? Now, what's cool about this is I just created a file called class.txt with just using my echo here and then a redirect with class.txt. Could as simple as saying as class-1.txt and did this and say new class today, right? By hitting I for insert, as you can see, the insert shows up at the bottom. I hit escape, I hit colon, I hit WQ, and I hit exclamation point. Are there other ways to do this? Absolutely. And I'm gonna go back into this again. I'm gonna vim this file again. I'm going to now use my O for give me a new line and insert. So O gives me a new line and insert. So insert new info, but instead of doing escaping colon WQ, I'm just gonna do control ZZ. Oops, get out of it, escape. And so now when I did control ZZ, what do you think happened? Well, let's find out with our famous reading of our file, class-1 text, right? You see new class today, right? You see that? It saved it. So let me see if they have a ZZ on here so you can see it. Let me do a control F. Do they have ZZ on here? Am I not on the page? Control F. Oh, it's Command F. I'm on, so used to being on that Windows box. Right here it is. Let me see if they got 2 right here. So you can WQ or you can X or ZZ to write and save and quit in Vim. So this is just again just a little cheat sheet gives you different things that you can do and move around in Vim, and it helps you. I'm not gonna say memorize this. I'm just gonna say just have it with you sometimes. Just pull it up sometimes so you can figure out, well, how do I jump from line to line or word to word or go to the beginning of the line or delete everything from the right side of this word to the left to 5 sentences down, like just different things like that. And in your head, you're like, what I would do is I would just download the file and use Notepad to highlight and delete and then save it and upload it back up. You can do that too, right? You can do that too. But if you don't have access to download something, sometimes you have to do it in real time. All right, so over here, they're saying standard in is 0, standard out is 1, which is when I catted that file, that was standard out. Standard in is like me taking in stuff for the keyboard right here, and they tell you it's right. The standard error will return like there was some type of error, and then here they're saying read and or write, right? They're just saying other files, like other file names. So you could go through this diagram, but I think this diagram works and doesn't work. So let's go through here. So here, I did this one here where I used echo and I created the file, right? And I threw something in here. But let's look at this one here because they got a double append to it, right? So clear whenever I type it, right? And let me show you another trick. I'm just gonna type some stuff here. And then if I type history, And if I go back and look at clear, which right here, number 18, I can just type exclamation point 18, and it's gonna run that command for me, right? So I can do a history and then run the command again without trying to remember what I did, or you could do a reverse search, or you can do an up arrow, as you can see. And I'm just pressing my up arrow, and it's just going through all my commands. All right, so then let's control C out of that. And so we had this file called class.txt. I'm going to append information to that file. So let's cat class.txt. And now I'm going to append information to that file using echo DJ clue. DJ clue, Cluminati. And we're going to append to class.txt. Right now, I'm going to cat class.txt, and I should see DJ clue. Right? So there's DJ clue. I didn't create a new file. I just appended to the file. I just added more content to the file by using my two, is this considered less than or greater than signs? I guess you could say greater than because it's this way, but you know, DJ clue gets appended to class.txt, right? And that's what they're showing you here. Redirect standard output, append to a file, redirect standard output, overwrite a file, or create. So when they say overwrite, now before, remember now, I have hello and then class.txt, but if I just take this away, it's gonna create a new file, and then class.txt is gonna just be DJ clue, right? So there's two ways I can write, right? You know what I'm saying? I'm overwriting the file, or I'm going to append to the file here. And when I do my echo like this and do it like that, I'm overwriting the file, right? But if the file's not there, you're just creating the file. All right, so then they get down here and they show that the file standard error to overwrite a file. So here, hey, if I get an error, you know, redirect standard error to overwrite a file, basically put that information into a file. Here, I'm gonna send stuff to /dev null. And I feel like this curriculum has been updated from what it was before. It wasn't like this before. They didn't have this detailed information before. They did some updates. I could be wrong, but I don't remember it being this detailed. So here they're saying redirect standard output and standard error to the same file. And they're saying that you can do it this way and this way. But I think when you are writing a script, you can't use the ampersand. You have to write it this way, if I'm not mistaken. And then here, we're going to take redirect standard output and standard error and append it to a file. And they walk through this. So here, let's look at what they're saying here. Let me go. I'm trying to see how much we got to go. All right, cool. All right, so it says the order of the redirection operations is important. The following sequence redirects standard output. When I say standard output, I'm catting the file to redirect standard output to a file, and then redirect standard error to the same place. So they're saying that this does that. However, the next sequence does redirection in the opposite order. This redirects the error to the default place, and notice the location of file, right? File, standard error, standard output. Here we got file on this side here. So however, the next sequence redirects in the opposite order. This redirects standard error to the default place for standard output, and then redirects standard output to a file, right? So this output is going to go to a file. And then they break this down here as to what this means. It says, however, other system administrator programs also use other shells related to bash for scripting commands. Think that newer emerging redirection operators should be avoided because they are not standardized. Got you. Right? So these things are going to be on the test, right? Just, and you're going to use these throughout, right? Redirect stuff. Right? So now they're giving some examples of redirects. And that's what I was doing. So we have date, and it's going to create a file in /temp and call save timestamp. Then here, we're going to say, hey, give me the output of var/log d message, but give me the 100 lines of that output, and then redirect that into last 100 boot messages. So create this file in /temp and call it last 100 boot messages and put that information there. Now here, they're saying we're going to concatenate files. So we're going to take the output of all these files, and then we're going to append them to all four in one right here. And then here they're saying list the home directory, hidden, and regular files. Okay, so let's go over that. So inside of my home directory, I do cd tilde, gets me home. If I do an ls, I see these two files and the kind of config, and let me exit. Let me go to my home. Hold on. Ls, nothing there. Oh, yeah. Let's go home. Clear. Ls. All right, here's what I have. You see these directories, but there also are hidden files. If I do a ls-a, everything that has a period in front of it are what we consider hidden files. And you can even see hidden directories as well too. All right. So let's go back. So they're saying in here, append output to an existing file. We did the echo, and then we append it to an existing file, right? This right here tells us that we are appending to a file. And then they're like, well, get the differences between these two files, right? So let's go here and look at diff. So man on diff. So compare files line by line, right? Here, like we said, we got the command, the options, and then the arguments, right? So let's do this. Let's go back over to temp, and let's do a diff on class.text and class-1.text. Now notice, let me clear that so you can see it at the top. Notice they have DJ Clue, DJ Clue 2, and DJ 1. So let's look at this. What's in class.text? It's cat class.text. So in class.text, I have DJ Clue and DJ Clue 2. But in class-1.text, I got new class today. So either, if I want them to be the same, I need to either input these two lines into class.1 text. So, somebody hit me. I need to put these two lines into class.1 text, and I need to put new class today into class.text, right? And so, let's see, let's get a better explanation so when you're reading this, Linux, let's see. Got that. I don't know who's in here yet. All right, cool. All right, so let's give examples. All right, so here, they're showing, hey, symbols are add, see, change, and delete. Let's see, did we get any of that? I don't think we got any of that. See, we only got the arrows. So let's go back and do a man on diff. Let's see if they got some options that we can output with. Well, let's try that. Let's see what happens when we do a diff with a dash Y. I don't like how that came out. That's because my screen not big enough. Hold on, let me shrink it. Oh, that's a mini more. Zoom. All right. And can I span it? And let's clear that. And let's see if we can get it side by side. Okay, so see, you see how I put it side by side? And that's for me looking at the arguments. So in class.text, I have this, and in class1.text, I have new class. But basically, if I want to get them the same, whatever the difference is between them, I need to make that happen. And so here, they kind of go through and try to show you what each one means. So look right here. It says, let's take a look at what the output means. The first line of the diff output will contain the line numbers to the first file, a special symbol, and then the line numbers to the second file, right? So here they're showing the line numbers and so forth of where they're different at, right? And then they walk through this. I'll give you this because this is a good example. It's pretty detailed to show you what it is. So here they're using the -C command, and the -C says context and unified mode. To view differences in context mode, use the -C. Let's try. I don't want to use that one. Step down here. They have a -U unified mode. And then the -I by default is case sensitive. And then to make the case insensitive, use the -I. So whether you got large letters or small letters. So diff is important. It helps you in your scripts. If you're want to do something with scripts, I drop this down here. All right. So let's go back. Then they say, okay, now we get into the fun stuff. The find command. Let's get into having some fun. Any questions so far on diff, echo, append? We're gonna get into standard error, as you see here, standard output, and so forth. Any questions? Let me give me some water too. Yeah, before we get started. 1 second. No questions? Okay, cool. Hold on, let me expand my people so I can see, because I can't see everybody. All right, cool. All right, so when we get back, we're gonna use the find command. And I wanna see how advanced you all are with this. So for those of you, I'm gonna go get some water. For those of you that have a terminal open or even the man pages, you can go and do this because we're gonna, as a class, we're gonna do this. I wanna do a man on find. All right, we're gonna do a man on find. And you can use whatever man page that you want here. But let's look at what's happening. So before I walk away, I don't have like a little sheet that I could put down, but that's okay. Explain what we're seeing here when we're looking at a command. What is this right? What's this part right here? This is the find command, right? We don't have any options that we're passing. So this is why I say you need to learn how to read the man pages, right? And you can read the man pages on the machine. So let's do a man on find. Right? So find, search for files and directories, and then they give you different options down here that you can use in order to find stuff. And find can be piped over to regular expression and so forth. Inodes, inames, permissions and so forth. You can do a lot with it. So give me like one hot second. Let me get my water. And then we're gonna go from there. So let's get right here. We're gonna start off with let me see. I want to start off with Ronald and Lori on the first one on the find command. I want y'all to work together to tell me what's going on and help explain it to folks. I'm gonna give you 1 minute and I'll be right back. Let me get my water. Everybody gets one, but I'll be right back. Let me get my water. It's all good. It's
Oh
just
no,
a fun.
I'm familiar with fine.
Yeah. Yeah. So
You
give me
what?
1 minute. Let me get some water
Oh,
real
you need
quick.
some time? Okay,
Yeah. Let me just get some water. It's snowing outside and the heat is on, so I'm getting kind of parched. Hold on.
gotcha.
All right, we're back. Okay,
Okay.
so the first things first, the find command can be used in scripts. It can be used in just on the command line itself. Um, it can be used a number of ways. I'm just gonna run the command, but Lori and Ronald, I want you all to work together. And anybody else, feel free to join in. But I want y'all to get used to being able to read and work together on what the commands do and what they say and how to read them, right? So let's just highlight this command here. Because here's the one thing I do know, that inside of etc, there's a file called password, and it's just going to return me error. So let's see what this command actually does. Let's clear, and then I have paste turned on right here that tells me that, and I'm going to use Apple V. I'm going to paste that for me, right? Okay, cool. So what happened? Ronald, let's get you and Lori to take a stab at it. Lori, you can come off of mute. You ain't gotta be on mute. I see you. Let me send you mute request. Unmute
Okay.
request. There you
Um, from what I see here, we're doing a find on the Etsy directory for a file named for PSSWD. And any errors would be redirected to /temp errors. But I think one of the things that was strange to me that this will work is because I mean I use filing very often, usually with the exact option. It was weird to me that you didn't need a double quote around the string. I usually put a double quote on there, but because I guess maybe I think on Solaris it works slightly different. But yeah, um,
The double quotes is nothing but you reassuring that it passes as a string.
Yeah.
That's all that is. Now, how did Ronald come up with this? Well, let's go back to our information, and let's also do an ls here, and we see that a file got created called well, should have been a file, but it looks like it was a directory called errors.txt. All right, so let's see. Let me do ls by myself. Oh yeah, there it is. That's a file. I don't know why I was seeing a directory. Yeah. Oh, because it's the way it's printed, but it's a file. Okay, so if we cat errors.txt, you can see first off, who am I? Oops. Is an issue, right? Because I'm a student trying to access the XC directory to do certain things. And so there are certain folders in the XC directory that I just don't have permission to. And it captured those errors for me. Now, how did Ronald come up with this? If we go back up here to our file up here, right here, I guess our legend, you can say, redirect standard error, and this says overwrite a file, but we created a file called file.txt. I mean errors, not file.txt, but errors. And so basically it sent those errors into a file. And that's what we saw when we did, let me do my up arrow here. That's what we saw, right? We said, hey, dash name. So again, we got to remember in the man pages, oops, Control-C, man on find, and we can do a search by doing /-name, right? And let me come out till it comes up. There it is. So dash name searches for a pattern, right? It's searching for a pattern, and that pattern was password WD. But let's go back and let's change this. And instead of looking for password WD, let's look for group. So it found everything in that directory, and look, it's recursively looking down because IP route 2 is an actual directory, and under that is group. So now I'm gonna have a list of errors that it's gonna return a new list, right? See, it's different, right? So that's what happens. That's what happened there. Let's look at this one. Here, what do you think is happening here? Joan, are you still here? No, Joan's gone. Okay, so let's go through this. We're going through the same thing, right? And this time it's gonna find password WD, append this to temp output, and then what? Append output to errors. So let's go here, let's try it. Let's see what happens. And it's gonna overwrite that errors file. So let's clear, and then let's paste. All right. So I'm not getting anything on my screen, right? So let's first look at temp output. So temp output gave me what I said, right? It gave me that information. And then we have another one over here that says temp errors. So let's go and cat errors. Oh, not car errors, but cat. And you can see where it did a search. So let's do this. Let's remove our errors. right? And let's clear the screen. RM will remove it. And let's run the command again so we don't make sure that we're not just getting the same stuff. All right, now let's look at cat errors. Yep, so we're making sure we're getting the right, output here, right? So that's what it searched for. It searched pass WD, put it in output, and any errors, go ahead and redirect them to temp errors. And same here, instead of it going into a file, it's going into oblivion. That's what dev null is. Send that, discard the errors. So we're not gonna even have a file anymore. And I'm gonna show you, you're not gonna have a file anymore. So let's do a date, 2130, and let's do an ls minus L on errors. And that was done at 2129. We're gonna paste this command. We're gonna hit enter, and we're gonna do a ls minus L on errors. It still has the same date, so it's not outputting to errors, and we know that for a fact because it's going to /dev null, but temp output should still be the same. Right? You all see that? Are you following along?
Yes.
Okay, cool. All right, so the next one with find Etsy-name password, look at what happens here. We have that ampersand, right? So we go back up here to our chart. We got ampersand file. So here we're gonna get a redirect standard out, and standard error to overwrite the same file. So they show you here that the 2 and the 1 are going into the same file, right? And they're just giving you another way to write that, right? So ampersand file. So let's go down here, and let's run that command. Let me clear my screen. And so now you can see if we cat /temp save both, you can see where it found the information and it also printed the error to the same file. And they're just showing you here that this and probably this are going to be the same. But let's run it. All right, so let's go back. Let's clear my screen. Let's go here and run that. What do you think? Look, but here's what's gonna probably throw you off. Look, it's appending, right? It's not creating a new, it's appending. So let's go back and hit it. And then now let's cat save both. So if you gotta look at what it did now. It did the same thing again, except it just appended what it did up top to the bottom of the file. It didn't create a new file. In other words, it just appended the information. And we know that just by looking at this little part right here. That makes sense to everybody? So we've been using the pipe command, right? Here it is right here, just so people don't think I'm like making up words and stuff. Get your mind out together there. A pipeline sequence of one or more commands separated by the pipe character, right? A pipe connects the standard output of the first command to the standard input of the next one. What are they talking about? So let's clear. So I can do something like this. I can go clear, and then Well, let's do this. Let's do ls minus L and pipe that over to grep, ignore case, and then give me pass WD. I mean, out of etc, pass WD. Oh, sorry, I need it all the way. My bad. And then let's grep, pass WD. That's what I want. So here you can see I ran a command ls minus L. I continue the command with the pipe, and now I'm using another command called grep, and I'm ignoring the case, and I'm looking for just password WD. I can also type in login, and it's gonna find me everything in that /etc directory because I am in etc. Oh, come on. Right? /etc pwd. And then grep -I login, I ignore the case because could have a capital L for login or whatnot, but I'm ignoring the case. So here, they're gonna show you different ways to type command. Remember, I have a command that's gonna give me some output. I'm going to take that output and use it as input to another command. But usually what happens when we're doing this, we're manipulating data, the output of data from one situation to another, right? So ls user bin, and then pipe that over to less. So there are different commands, like if we do a man on less, the opposite of more. It is. It is absolutely the opposite of more. What they're trying to say is showing you the top of the file, the top of the output, right? And then head, more. So let me do this. Let's do a ls minus L, and then pipe that over to less. And then if I do pipe that over to more, let's see if you see the difference. So let's do this. Let's do ls. Let's use our tools. Let's do ls minus L, pipe it over to less, and then redirect it to less.txt. You won't let me do that. Let me do it in temp. And then let's do an ls on minus L and pipe it over to more. And then let's do it on, put it in /temp more.txt. So you see where I'm doing an ls, that's my command. I'm piping it over, taking that output, manipulating it with more, taking the output of that and storing it into a file inside of temp. All right, so now let's go to temp. And you remember that command we used earlier? Let's do ls. Let's do a diff on less.txt and more.txt. Look at that. It didn't find any differences, right? It didn't find any differences. So let's do a cat on less.txt and pipe that over to head and give me the first 5 lines, right? And now let's do the same thing with cat on more.txt and pipe it over the head and give me the first 5 lines. Don't find any differences, right? It said it's the opposite of more. So you use either or, more or less, right? All right, so here it gives me word count. So I could do a cat on here, and I could do WCL and it's gonna list it line by line. And I can do the same thing with less.txt. Now, another thing you can do is man on WC. Because right now I'm doing line by line. So it's literally going through and doing line by line. But what if I want to print out the number of characters in that file? So let's do that and then type C. Now that tells me how many characters I have in that file. We'll go back. You can see, bytes, not characters, but bytes. And then M is the character, and then the L is so let's do characters. So I got the number of bytes. So let's do M, same thing, right? It's giving me different things different options I can do. And so here, now we got an ls minus t. Oh, well, what is ls minus t? Before you run it, do a man on ls. And then dash t, you can do a /-t. It should come right to it. Let's see. Getting closer, there it is. Sort by time modification, newest first. All right. So sort by time modification, type that over the head, give me the first 10 lines and store it in a file called and /temp under 10 last change files. And that's what it's going to do. So when you come here, if we do a ls minus t, you see that it's giving me the last files that got changed, right? So let's cut and paste. Let's do it in the directory we're in, because I don't think we changed anything in etc, so that's not a fair shake. All right, so now if we just do a cat on /temp 10, that's file. So here's the files that got changed in this directory. But you can also see that system D, I think those are directories. So it got the files in the directories. Is this checking out for everybody? All right. So we did this. We did ls, stored into a file, and then let's read it to us. So in this example, the ls command goes to the file and displays nothing on the terminal, right? So let's do that with our file. So let's do an ls. Well, we can do that. We can do that here. We don't have a save temp. So, well, yeah, it'll create it for us. And nothing happened. You see that? So, but if we cat /temp saved output, got some information in there, but the less didn't open up the file and then read it, right? We got to open up the file and read it. So the T command overcomes this limitation. The T command right here, right? I have a standard output, and I'm gonna use a standard in to a process, to something, and the T command is gonna read it. So here you're gonna give an example. So I'm gonna ls this information, and then T this information, and then do a list. So let's show you how T works. Disclaimer screen. All right, we know what the ls is gonna give us. And then the T command, we're piping it over the T, is gonna read this output that's getting saved into /temp saved output. And the last command, it won't be a blank screen anymore, right? And then we're gonna queue for quit. All right. And then let me do this. Let me remove saved output. And it's clear and run the command again. So you can see that it actually gets written. And then let's do ls. Saved output is written. But it had to show something so Les could do something with it. All right. Here we're doing the time modification. We're gonna just get the first 10 and then T that to that file. It's gonna just pop up and you're gonna have to quit. All right. So here it says standard error can be redirected through a pipeline, but the merging direction with the ampersands cannot be used. That's what I was talking about earlier. You can't use those ampersands when you're doing like through a pipeline, like this. You couldn't use the ampersand like that and the ampersand like that. And in this section, they got you're doing a quiz. In this section, they talking about editing files with Vim, which I went through. Workflow, and then they talk about rearranging with Shift V, Control V. Don't forget to use the cheat sheet. All right, and that's it. So let's walk through some stuff. Let's Vim, etc password. Right, so if I want to go down the line, I can just use my arrow and go down. Right, one at a time. If I want to do a whole page, you should be able to use the space, but I wasn't able to use that. Hold on. But you can see my columns are changing. All right, so now this is where you start playing around with the cheat sheet, right? I mean, when you're using the H, the O, right? Jump to the last line of the file, G. So if I do Shift GG, I'm at the bottom of the file. If I do G or Shift G, oh, is it double G? Oh yeah, double G takes me back up to the top. Shift GG takes me down to the bottom, right? So they're just showing you how to move around in the file here. And then they're talking about Shift V and Control V. Well, we call them yanks. And you see that right here. Let's see, Control F, we'll go yank. All right, so in visual mode here, right? Start in visual mode and then yank stuff. Yank is a copy. And so they're showing you here how to yank stuff that it goes into the register. So you can yank and basically cut and paste, right? But you want to cut and place like 2 lines, right? So what they're talking about, Tweak? Here, Control V. Oh, come on. Is it? Do I have to use Apple V? No, that ain't it. How can I do it? Let's see, Control V. Will it work? No, it's not working. So I may not be able to do it. There you go. So I didn't like my keyboard. I'm on a Mac, so I didn't like it. So I used the keyboard that they have on there. So as you can see, I'm highlighting text, right? You can see I'm highlighting text. That's what Control V gives me, a visual block of text. And then I can do, I'm gonna have to use the keyboard. Control, insert with the I. And let me get rid of that. It should have went to insert mode. I may have to do this on my Google account. Basically, I should be able to control visual. I should be able to, if I just hit shift, I should be able to do shift insert. There we go. And then if I did an O right here and then hit escape, you see it, where everything I had highlighted before, it went through and put an O there. Now, if I don't want to save this file or whatnot, I could just write, I just can quit. But if I just want to undo what I just did, I just hit U to undo. Right. And it's funny, they don't go into all of that here. But inside of your lab, you're gonna get a chance to play around with the Vim tutor, and then you're done. So just walking you through the Vim tutor there. And here we're setting variable names and changing files. All right, so let's go through this real quick while we got some time. And I can finish the rest of this next week, but it's not that big of a deal. All right, so let's go through and set some variables. Escape, quit. All right, so I could say name equal to tab. And then I can say echo $, name is 10. All right, so I just made a variable equal to something, right? I can do number equal to, and then I can echo $, number, because it becomes a variable, right? There are variables that get set. Oops, let me go to root. So if you go to etc profile, this sets variables for the entire system. So if I want everybody in that logs onto my Linux box, or this Linux box, not mine, but any Linux box, and I want them to have, say, user bin Perl 5 in their actual profile, I can set that here. There are other ways that I can set the binary for Perl and different applications, but this is just another way as well too. Any questions so far?
No.
Go ahead.
Oh, no, I was saying no, no questions.
Okay. All right. So here again, I just showed you count, first name, file. Typically, I like to use what we were talking about earlier, single quotes or double quotes when I'm setting paths, because I want you to know that this is a path and not necessarily like cause any problems with these slashes. Here, we usually consider this a handler equal to RH23. It says, remember that change only affects the shell you're in. So if I close this out and came back in, I'm gonna lose it. If somebody logged into the machine, they're not gonna see those variables that I set, unless I set them in a global space like Etsy profile or in their bash RC or something of that nature, depending on the shell that they're logging in with. All right, so here you can use the set command to list the variables, to list all the shell variables that are currently set. It also lists all the shell functions, which you can ignore. This list is long enough. You may want to pipe the output to less so you can view it on one page. And so here, I'm gonna quit, and then let's clear, and then saying set, and you can use more. All right, so you can see that these are variables and stuff that have been set. And you see the scripts that they're talking about, it's going to give you everything. Another one is env. Gives you environment variables that are set as well too. So pwd is set to root. Host name, if I type host name, It's set to workstationlab.example.com. But if I also go to this cat etc hostname, you can see that this is set here. 9 times out of 10, it's reading from this hostname file and not necessarily from host name. But I can change host name to be class dot lab. Let's do class dot one because it is one called class dot lab dot example.com. Right, and then let's echo $ host name. So you took the variable that I just said, right? Let's set it back. So now let's use the up arrow. Let's just put workstation. Another place that things can be set is in /etc host file. Right? So you can see I have an IP address associated with this actual full domain name and the short name workstation. Right? So basically I could do something like ping server A. Right? And then if we go over in here, it says retrieving variables. Like if I echo count, I'm just gonna get count, but if I echo $ count, I'm gonna get the variable. Here they have file1 set up to a path, but then if you do ls minus l on $file1, you'll see that it's giving you /temp, so forth, so on, and everything. And then you can remove file1, $file1, which is going to remove this particular file. And they're showing you configuring bash shell. So we talked about this before, but remember I said you have, oopsie, where we go. You have the username. I mean, I can go here and show it to you. I need that real quick. Remember, you have the username, the host, you have the path in which you're at. You have this dollar, meaning it could be a $ or a £. And also included in this are these brackets as well too. So let me show you what I'm talking about. Is this the right one? I feel like, yeah, here it is. All right, so look, so PS1 is equal to bash /$. But they got it right here, right? So here they got the user at the host, the working directory, and then what the actual whether you're a user or a root, or I don't know what's the correct way to say that one. I'm not sure what's the correct way to say that. Because that $ could be something else. You could make that $ whatever you want it to be, right? But they're showing you here the two items above. First, above the example, first because the value set by PS1 is the prompt. It is virtually always desirable to end the prompt with a trailing space. That's what they're talking about here. Second, whenever the value of the variable contains some form of space, including a space, a tab, or return, the value must be surrounded by double quotes, unexpected results, and so forth. So let me see if they give you some more information up here. They don't, right? But this is the user at host, and you can see that here, user at host. And then the next one up would be the working directory, which is this $. And then so if I CDO with a temp, you can see it changes, right? It gives me where I'm at, right? And again, like I say, you can just type PWD. You can look right here to see where you're at, but sometimes you may be in var/temp. Let me see var/log. right? So you don't know that you're in var/log. You could have been in Tamika/log or home Tamika log, right? So it's always good to type PWD to give you true clarity of where you're at. And then they talk about configuring environment variables. I just did that. The date command, just type date. Echo path, I showed you that. Here they're appending. So here they're saying, hey, I want to append a new location to my path environment variable. So I'm going to take path, and you don't have to do it like this. You could do $path and then expand by adding this location to your environment variable, right? So that's one way. And then the next one up is export the editor. We talked about editors. And then automatically setting environment variables. Again, like I said, it could be in profile or the bash RC. And then to unset them, you can do unset to unset a variable if you want to unset a variable. Right, and then they send to unexport something without unsetting it is export -n. And we can go here and do a man on export -n. Well, export. And let's do -n here. Let's see if they give us an option. Take off the -n. For it. All right, so let's see, I see the -p, the -X. I don't see the -n. Did I have that option? Maybe it's buried in here somewhere. Action, F, capital. I don't see the, there it is right there. Give each name and their reference attribute, making it a name reference to another variable. The other variable is defined by the value of the name. So in here they gave a -n, export -n PS1. To unexport a variable without unsetting it, use that. And that's it. That's all of chapter 5. I think, yeah, you have a guided exercise, and then you have a lab, and then the summary. Maybe if I didn't take a 1-minute break, we could have got through chapter 6 in a minute. Maybe.